Assalamualaikum and Bismillahirrahmanirrahim. My name is Muhammad Nazir Izzat and I'm the group leader for the team Group 4 Section 1. So today I'm going to present about the case study for elbow surgical plan. So the objective produce a case study to choose the most appropriate materials and its process for elbow surgical implant. There are 4 strategy steps in selecting a suitable material on an elbow surgical plan. So this 4 steps is translation, screening, ranking and documentation. So for the first step, the translation. The design requirement will be defined in this step. The function, constraint, objective, and free variables will be defined. Every material has its own strength and weaknesses. By defining these properties, we can identify the most suitable material. So the function is to use to replace elbow bone part. The constraint is high wear resistant, high corrosive resistant, biocompatible, and high fracture toughness. For the objective, is to minimize the mass, maximize the fracture toughness, and minimize the cost. And for the free variables is metallic materials, choice of manufacturing process, and of course the choice of materials. We pick metallic materials because we know that non-metallic material has a low wear resistant while metallic material has a high wear resistant. So that is the main reason why we choose metallic materials instead of non-metallic materials. By using a CAS software as a database to pick the suitable material. And then we generate the graph of Young modulus consistency from the software so that we can identify what are the materials. So for the step 2, which is screening, to achieve the objective of the elbow surgical implant, we have set the constraint and limit in the CES software. 5 materials have been picked from the database. These 5 materials have passed the limit and constraint that we have set. The properties of these 5 materials will be collected and screened so that 3 materials will be selected and by utilizing the limitation that we have set. This is the table for the 5 selected materials with its comment and justification. For stainless steel, it has a high value of M1 and M2. For titanium alloy, it has a high value of M1 and the most expensive material among these 5 materials. And titanium alloy is also the most biocompatible material. For copper, an acceptable value of M1 and M2. Next is brass, an acceptable value of M1 and M2, but it's not a good biocompatible material. For the bronze, it has lowest value of M1 and one of the lowest value of M2. And bronze also is a good biocompatible material. After a careful analysis, brass and bronze will be eliminated. This is because brass is not a biocompatible material. The price for bronze is also quite expensive, even though titanium is the most expensive, but it is the most biocompatible material, so it will go through the next stage, which is the ranking. The third step, which is ranking. After screening, the 3 materials that will be ranked is stainless steel, titanium alloy, and copper. These 3 materials will be ranked based on the properties, which is density, fracture toughness, hardness, and price. The materials will be ranked each of its properties by using a scale of 1 to 10. So, after totaling all of the score, we will go to the step 4, which is documentation. After totaling all of the score, stainless steel has the highest score, while titanium alloy is second, and copper third. Stainless steel will be chosen as the material for the elbow surgical implant. Since the implant consists of 2 parts, which is hinge and stem, so 2 material is needed. For the stem, stainless steel will be picked, and for the hinge, titanium alloy is chosen because it has a high wear resistance. Hinge will have lots of movement, so a high wear resistant material is the best choice for this part. So that is why titanium alloy will be chosen as a material for the hinge. So that's it for today. I'm going to pass to the next presenter.
So I'm the next presenter. I want to tell about processing parameter for both stem and hinge. So for the first stem is need to be durability and strength, and the second one is the height. The weight of the stem must be not too heavy. The third one is the tolerance, which is we need to make sure it's tolerate so it can fit in the place. And the fourth one is the wear resistance, since it will involve a lot of movement. And the last one is the corrosion resistant, because we need to make sure it's able to withstand the chemical breakdown occur on the material environment. So for the hinge, first we need to make sure the hinge must be a ductile, since it needs to sustain large permanent deformation under tensile load. The second, low electrical and thermal conductivity, because we need to make sure it not attract to magnet and the person to use it not getting shocked. And the third one is the high tensile strength, which can make sure the hinge, which can make the hinge to be used more longer. And the last one is the corrosion resistance, is the same as stem. And procedure step to produce steam and hinge is first the material is heated, then we mix the material and combine it with thermoplastic binder, then the melt materials is inject into the mold. The first one, the solidified material is then removed from the mold, then the part then undergoes polishing process, and the last one, the both part is then combined with a paint. So we can see the procedure are including injection process and also chemical polishing. So that's all for me. I will pass it to for another presenter. Thank you.
Based on the flowchart, we can see there are several steps to manufacture elbow implant. This medical data modeling process involves the image processing step. The model of the hinge and stem implant was scanned by using the CT scanner and construct on the PC and slice. The PC then controls the material to be deposited on the operating platform. The data construction then conducted by CAD/CAM software to execute the segmentation of the anatomy through complex 3D selection and editing tools. This software also produces high-resolution 3D rendering in various colors directly from the slice information commonly used for shaping and joining process. After visualization is done, the data is interfaced to CTM. The CTM software interpolates the medical slice in thin layer and interfaces rapidly with the shaping and joining process system. Before shaping process begins, the material were analyzed for their capabilities and were defined to produce the implant. The data that interface from CTM software helps the shaping and joining system to start fabricate hinge and stem implant. The shaping and joining process then transform the data into the real part of the hinge and stem one by one until the implant model is complete. The hinge and stem implant model produced then through the finishing process to alter the surface of the part to achieve a required characteristic before the consideration testing is performed. The implant model are ready to be used if they pass the test, otherwise they will go through the process again.
Assalamualaikum, my name is Muhammad Al-Haziq bin Muhammad Sarudin. I would like to discuss about the manufacturing process selection strategy. There are 4 steps in the selection strategy, which is translation, screening, ranking, and also the documentation. For the step 1, translation. Translation is to list down about the function, the constraint, the objective, and the free variable of a shaping method for the producing the biomedical surgical implant. And then the screening table. The screening table is to list down about the properties and also the process that we have choose. And then the ranking table will be done. The ranking table is to numbering the range based on the screening table. And then the documentation is for the last step. The documentation is to summarize why we choose the injection molding for our process. Thank you.
Hello, my name is Muhammad Saifuddin. I will to explain the effect of parameter on the product design. Firstly, about the material properties, we have seek the effect of the parameters for the material. Firstly is the durability and higher tensile strength, which is the stem and hinge need to the long term and strong enough for the time frame that the patient or the user use the stem and hinge. Next, the weight. The weight we need for the stem and hinge lightweight, and it will need to comfort with the user. Okay, next the tolerance. The tolerance is very important for the manufacturing process because the tolerance will depend the accurate for the fit for the stem and hinge to make sure the product accurate to fit it. Okay, next the wear resistance is the characteristic we need to take care because the stem and hinge are always in motion for to make sure the material is in good condition for the long term. Next, the corrosion resistant. The corrosion resistant is very important for the medical engineering for make sure the product or the part of we need to help people is not in infection. Then other than that, the stem and hinge need to withstand deterioration and chemical breakdown that will occur on the material environment also. Okay. And lastly, the low electrical and thermal conductivity. This is important because the hinge and the stem is provided from a metal. So we need to make sure the hinge is weakly attract to the magnet and electricity because we need to prevent from the shocking or lightning. Okay, the next part is process parameters, which is we have 4 the parameters. It comes from the material, economic, tolerance, and surface roughness. Firstly is material. For material is we need to specify the chosen material. The material we choose is stainless steel. Okay, for the second point, the economy. Due to the product using the stainless steel, it show the product can be a recycled back. Okay, the third point is tolerance. Tolerance for this process parameters important because we need to make sure the product and steam and heat fit to the measurement. Okay. The lastly is surface roughness. The surface roughness is important because the higher surface roughness give a poor product for users. Right. Okay, this is all from me. Thank you.
Assalamualaikum. My name is Khairul Shakir bin Khairul Munir. Today I want to explain about quality control and testing. For quality control, we have to make sure that the product met the minimum requirement that has been set at the constraint. Our constraint is high wear resistance, high corrosion resistance, biocompatible, high fracture toughness, high fatigue resistance, and low cost. And for high wear resistance, the testing is to treat the surface condition of some real joint pipe with testing condition be controlled as close as possible to those for real human joint. For example, we use a human body fluid at the product so we can see the wear resistance of the product when contact with human body fluid. Then high corrosion resistance, a salt spray test will be used to check corrosion resistance material for the surface coating. Then for the biocompatible, an appropriate biocompatibility testing will be used on the material. There are many biocompatibility testing and we will select the most suitable one for our products. Then next one is high fracture toughness. Fracture test will be used to test the maximum and minimum toughness of the material. The most common fracture toughness test is Vickers test, where we'll be punch the material with a diamond shape puncher, and we will calculate the dent of the material to test the product toughness. For high fatigue resistance, a fatigue test will be used to determine the material ability to withstand cyclic fatigue loading condition. The material will be used in cyclic routine to test the fatigue loading condition. Then finally is the low cost. For low cost, our engineers will select the most suitable material for the product that met the requirement of the product, that is a low cost. For this test, we will use the CES ADU pack to select the most suitable material with the cost in mind. That's all from me. Thank you.
Assalamualaikum. Hi, my name is Muhammad Naim bin Muhammad Rosli. Okay, now moving on to the defect and countermeasure of elbow surgical implant. So, firstly, the material used have the possibility to wear out in longer period of time. And countermeasure of this problem is use highest durability material that are available accordingly to all the spec needs to build the implants. Secondly, metal injection molding process has multiple steps which lead to more expensive process costs. So how we can solve this problem is eliminate undercuts and get rid of unnecessary feature and try as much as possible to reduce cosmetic finish and appearance. Next, there are only small part production during metal injection molding process. So we can consider part size of the manufactured parts in the implants manufacturing process to avoid this problem from happening. But there are some other implications could happen too, such as porosity, contamination, and cost. For the porosity, we can choose material that need to be used is the material that are capable of staying underwater or wet condition for a long period of time. After that, to avoid contamination, we have to make sure all of the material and mold used are checked on their cleanliness. And last but not least, we can reuse or modify mold in order to reduce the cost of the metal injection process.
So in conclusion, after doing this case study, we have better understanding on selection of the material and process. The selection of material is crucial so that its function can function properly. and a good selection of process can prevent defects and reduce the cost. So that's it. Thank you.